Unit 7 Review Questions 10 and 11. Talia went on a road trip. She traveled at a constant speed and drove 402 miles in 6 hours. Now the first question asks us to find the unit rate that Talia traveled in miles per hour. Okay. So a rate is a type of ratio where we're comparing two different types of units of measure. So miles is distance, hours is time, and miles per hour is going to be speed. Okay, so we're comparing two different units and we get this different type of unit. Okay. A unit rate is a rate where the denominator is 1. So we're going to write our result either as a fraction or a decimal, thinking of the denominator as 1 via division. Okay, just like with ratios, there's an indicator word where you see per. The value before per goes in the numerator, and the value after per goes in the denominator. So for miles per hour, we're going to divide 402 miles over 6 hours. Okay. Now I'm going to do this division on the calculator. 402 divided by 6 gives us 67. So we have 67 miles per 1 hour, and we use per language to write this at the end. So we'll say 67 miles per hour. And you may have seen this abbreviated as MPH. Okay, so this means in every 1 hour she traveled 67 miles. Let's look at the next one. Find the unit rate that Talia traveled in hours per mile. And notice that almost sounds the same, but notice how it's different. Okay, so hours is going to be our numerator, and our denominator is going to be miles. So we're basically reciprocating this rate, and we have 6 hours over 402 miles. Now, before we're going to write this as a decimal, but I also want to write this as a fraction, and this is going to seem a little bit odd. So with the unit rate, our goal is to get the denominator to equal 1. Okay, but I know from the previous problem that I could write this as 1 hour over 67 miles. Okay. So that's not a unit rate in hours per mile. We want to know 1 mile. But we could think of this fraction in a different way. We're going to write the 1 over 67 and now write this as hours per mile. Okay. So we're really thinking of this as 1 over 67 over a giant 1. So this is our 1 mile, and this is the amount of hours it takes to go a mile. So we do it this way so we can conceive of what this means. This means to go 1 mile, it takes 1/67th of an hour. So you could think since there's 60 minutes in an hour, it takes a little under a minute for her to travel a mile at this speed. Okay, and we can also estimate this with a decimal, so let's do that. And so we'll write approximately 1 divided by 67. We'll use 3 decimal places, so 0.015. So 0.015 hours per mile. Okay, so again, every mile takes about 0.015 hours to travel. Let's look at the next one. Penny is buying detergent at the grocery store. A 100-ounce box costs $12.23. A 75-ounce box costs $9.50. And we're asked, which size box is a better deal? And we need to justify our answer. Okay. So notice the problem here is that since they're different sizes, it's difficult to compare which one is a better deal. So if we can write them either, we could write ounces per dollar or dollars per ounce as unit rates, then we could compare the unit rates. So let's see how that works. I'm going to go with dollars per ounce. Find dollars per ounce for each. Okay, and you could do the other direction as well. Divide ounces per dollars. I chose dollars per ounce just because it will be in cents, and that makes more sense to me. But either way works fine. Okay, so the 100-ounce box. Okay, if I divide the dollars, 12.23, by 100 ounces, you might see it's going to move the decimal over 2 places, but let's just do it on the calculator later anyway to verify. 12.23 divided by 100 is 0.1223. 0.1123, and now let's write dollars per ounce. Okay, so what this means is for the 100-ounce box, for every ounce you're paying 11 cents and 0.23 parts of a cent, or whatever this is. Okay, I kept all of the decimal places because sometimes you have to go far out with the decimals to see how they compare. Okay, so 75 ounces. Well, this is 957 divided by 75 ounces. This one I don't care to do in my head, so let's divide on the calculator. So 9.57 divided by 75 gives us 0.1276. So 0.1276 dollars per ounce. Okay, so that means for every ounce, for each of the 75 ounces, you're going to pay about 12 3/4 cents per ounce. So now you have to make your decision. We weren't asked to find these unit rates. We're using them to answer the question, which size box is a better deal? So comparing these numbers, you want to think, well, do you want to pay more dollars per ounce or less dollars per ounce? And you definitely want less dollars per ounce. So let's write that. Okay, so 100 ounces is a better deal because it costs less dollars per ounce. So this states what the better deal is, and we justified it. Okay, just a note, if we found ounces per dollar, we would have gotten the same result, that 100 ounces is a better deal, but we want more ounces per dollar. That would be a better deal. So you really have to interpret this based on your life experience, which one makes more sense.